It is a very good morning, good afternoon, everybody. My name is Rodney Jacobs, and I thought that I would do a couple of videos every week just to keep things interesting. I'd also like to invite everybody that has joined my group. We are now 500 plus strong, and things are going along quite nicely. I thought that a topic that I could kick off with would be resolution. Now, we all have to have signals that come into our DCS systems and our SCADA systems and our PLC systems. And those signals are in an analog format and they have to be converted into a digital number itself. And the very important aspect that goes hand in hand with that is going to be resolution. If you look at the screen, you can see that we've got certain steps that we can try and break the signal into. The easiest way to describe this is if you were to think in terms of something such as a switch. Imagine if I had a switch and that switch of mine was going to go to a little light. Now that switch is going to be a single switch, and as such it's going to have one of two positions. And by the way, mathematically, if you want to know what that is, 2 to the power 1 is going to be 2. So there's going to be two combinations. My switch can either be off or it can be on. If the switch is off, the light is off. If the switch is on, the light is on. Now, what if we were to go and double that up? It's going to try and do that. If I was to go and put in a second switch with its own light, and the first switch is still there with its own light, I've now got two switches. So it becomes 2 to the power 2, which is going to be 4 combinations. In the case of one switch, the light was either off or it was on. That was my 2 combinations. With the 2 switches, you're going to find that these would be the combinations. I would get 4 combinations, of which 0 is the first, and we're going to have another 3 after that. So I can either have both switches off, one of the switches on, the other switch on, or both of the switches on. Those are the combinations. And just for the fun, I thought that what I would do is just call up a small little PLC program that I've just gone and written, and that shows you 2 switches. That switch can be on or off, and I've just used ladder logic, which we will get to at a later stage. That switch can be on or it can be off, or I can have both switches on or I can have both switches off. That gives me the 4 combinations, and so you can get better and better and better. You know, if I was to have 3 switches, it does mean that in that case, the combinations that I'm going to end up with are actually going to be 2 to the power 3. And 2 to the power 3 is going to be 8. So I'm going to have 0 and another 7 readings. I'd get 8 combinations: 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, and 0, 0, 0, 0, 1, 1, 1, 1. That is the idea that we're going to work behind. And this is where our resolution is now going to come to the fore, because we're going to have analog signals, and those analog signals from instruments out in the field need to go to either a PLC or a DCS or a SCADA system, each of which I'm going to speak about much later. And these will have to have a certain resolution attached with them. I can, for example, go for a 10-bit resolution, which is going to be 2 to the power 10. And that tells me that we're going to have 1024 combinations. In other words, the raw value that they talk about, or the counts that you'll see on your PLC, are either going to be 0 or they're going to be 1023 other combinations. If you were to have a look at a 12-bit card, that's going to be 2 to the power 12, and that is going to give me 4096 counts. For those of you who are Modicon users, that might be very familiar to you. If you were to go for a 15-bit resolution, well, 2 to the power 15 is going to give me 32,768 counts. Those are the combinations you get. So you'll actually go from 0 to 32,767. If you happen to be an Allen Bradley user, that would be more familiar with you. So just to get back to my first slide that we have over there, the higher the bit count, the smaller the steps that we are going to get in between the signals that we can go and work with. If you were, for example, to go and work with a 4 to 20 milliamp signal, and let's say that you're going to be working with a resolution of a 12-bit card, which is going to be 1024. If I was to divide that by 1024, I'm going to pick up 0.016 of a milliamp per count. And if I was to have a higher resolution, I'm going to get a smaller variation in milliamps per count itself. So this is very important for you and I. We need to be able to analyze the signals that are coming in and make sense of them. We need to pick up the smallest change that we possibly can. Now that's going to get us to other sections such as eliminating noise and the rest. It doesn't make a difference. At this point in time, we have discussed resolution. Now, this is not accuracy. Accuracy is a whole different kettle of fish. But we'll get to that over the next couple of months as we do more and more videos. That's it. That's my little video that I have got. Please remember, if you need anything more than this, get your training department to get in touch with me, and maybe we could put a course together for you and come and do it on site. All the very, very best. I will see you again with the next recording. Thank you.